Assalamualaikum warahmatullahi wabarakatuh and hi everyone. Okay, now we are in the topic of impedance in series and also impedance in parallel. Okay, we talked about the impedance before that involve the passive circuit elements which are resistor, inductor and also capacitor, right? Okay, let us revise about the impedance that we have learned before. If we have a resistor, okay, the impedance is called ZR equals to R. Okay, for the inductor, okay, we have the ZL which is equals to J omega L, whereas for capacitor, okay, we have ZC which equals to negative J over omega C. Okay, now all these impedance, okay, can be in series and can also be in parallel, or they can also be both in series and parallel. Okay, so when we talk about the impedance in series, for each Z1 here, actually it has their own V. So we call as V1 as the voltage, okay, across the components that has impedance Z1. And then we also have the V2, which is the voltage across the impedance that involve the components for Z2. And until we have another impedance Zn that involved with the voltage N. Now, when we want to see the relationship of this for this VAB, okay, the voltage across the terminal AB can be written or written AB, okay, can be written as V1 plus V2 plus until the Vn, because all these components are in series. Okay, so the summation of all these voltage is the same as the VAB, okay, at the terminal AB. Okay, and when we have seen before that we have a relationship that for each voltage it has a relationship with the I, Z. Okay, and with that definition, okay, we can also say that for V1 we will have I and Z1, okay, and because we know that all the current for each Z1, Z2 until Zn will be the same, so we just put I here, okay, and then plus for V2 is I Z2, okay, plus until we have the I Zn. Alright, so with that, then we can factorize the I, and we will have Z1 plus Z2 until we have Zn. Okay, and in that case, I can also write this as I multiplied with ZAB. Okay, so ZAB is the impedance at terminal AB, which is also the summation for all the impedance along the series of circuit. Alright, so we can also now write that ZAB equals to VAB divided by I. Okay, and this one is actually very much related to the Kirchhoff voltage law. So for Kirchhoff voltage law, it is said that for each V1, V2 until Vn, when they are all in series, so we can say that the voltage at terminal VB here is actually equals to the summation of all the voltage here. Okay, so that is related to the KVL. or Kirchhoff voltage law. Alright, now let's go for the impedance in parallel. Okay, so impedance in parallel is also the same as if we have the resistance in parallel. Okay, so if we look at the definition of the ZAB with respect to the Z1, Z2 until Zn, we can actually write it as 1 over ZAB equals to 1 over Z1 plus 1 over Z2 plus until 1 over Zn. Okay, so it's quite similar with 1 over RAB equals to 1 over R1 plus 1 over R2 plus until 1 over Rn. Okay, now for the current, okay, when we look at the current relationship, so if we look at this I, current I, okay, which is the current source that comes from the voltage AB here, it's actually similar to the Kirchhoff current law, where we can say that the current that comes from the source, okay, which is I, is the same as I1 plus I2 plus until In. Okay, so this one is related to the Kirchhoff current law. Alright, and when we want to see the definition in terms of the voltage, so since all the voltage at each Z here is the same, okay, they all have the same voltage here, so we can put that the V here, V equals to V1 equals to V2 and also equals to Vn. Okay, so that's one relationship. And based on this definition of Kirchhoff current law, that the summation for all currents here is the same as the current source, we can also write it as V divided by ZAB, okay, because since each voltage is the same for each impedance, so we can just write for current 1 is the same as V divided by Z1, and for current 2, I2, we have V divided by Z2 plus until we have current N, so we have V divided by Zn. Okay, so all of these are showing us how the impedance in series and impedance in parallel can be used when we want to solve our circuit analysis related to the steady state analysis. Okay.